let's move on to the Newton's law of motion. In 1687, Sir Isaac Newton stated 3 laws of motion. First one, the first law, the object is in equilibrium or moving with a uniform velocity or is at rest when there is no such unbalanced force exerting on object. Which means when considering this object, what happens? There are 2 forces. One is weight, the other one is normal reaction. Since normal reaction equals to weight, what happens? No resultant force exerting on the object, therefore object is at rest. When considering a vehicle moving with a uniform velocity, how many forces exerting on it along the horizontal direction? One is accelerating force, the other one is friction force. Since the forces equal to each other, what happens? Resultant is 0, therefore vehicle moves with uniform velocity. Right. Now we can move on to momentum. Momentum. What is momentum? Momentum is a multiplication between mass and velocity, is known as momentum. How would you get the momentum? P equals m into v, which means momentum equals mass into velocity. What is the unit of the mass? That is simple k simple g. What is the unit of velocity? That is ms minus 1, or you can take as Newton seconds. That is the unit of momentum. For example, we can consider an object of mass 100 grams moves with 500 meters per second. How would you get the momentum? Using P equals mv, mass is 100 grams, that can be divided into 1000 in order to convert kilogram. In order to convert gram into kilogram, velocity is 500. So what happens here? So the answer is 50 kg ms minus 1. That is the momentum of the object. Now we can move on to Newton's second law. What is Newton's second law? If the unbalanced force is exerting on the object which is directly proportional to rate of change of momentum. Rate of change of momentum. For example, we can take the initial velocity of the object as u. Due to the unbalanced force, the velocity of the object varies from u to v in simple t seconds. What is the changing momentum here? What would be the initial momentum? That is mu. What is the final momentum? That is mv. Changing momentum, mv minus mu. Therefore, rate of change of momentum, that is mv minus mu divided by t. So then we can conclude that the force directly proportional rate of change of momentum, the proportionally constant is 1 according to the SI units. So the equation is F equals mv minus mu divided by t, or you can take m into v minus u divided by t. This can be taken as your first equation. Then what you have to do is, since v minus u divided by t equals a, you can take the second equation as f equals ma. Second equation as f equals ma. Then you can consider this equation as well, considering m over t into v minus u. This is the third equation. This is the third equation. This can be used for applying the motion of rocket. So how would you get familiar with these physical quantities? What is capital F? That is unbalanced force. What is simple m? That is mass of the object. V final velocity, u initial velocity, t is the time taken, then m over t rate of change of mass. Those are the physical quantities. Now we can move on to example under Newton's second law. A vehicle moves with 20 meters per second, changes its velocity as 30 meters per second in 10 seconds. If the mass of the vehicle is 1000 kilograms, how would you find the unbalanced force? So you can take the initial velocity as 20, final velocity as 30, and the time taken as 10 seconds. Then you can use m into v minus u divided by t. M is 1000, final velocity 30 minus initial velocity 20 divided by 10. So the answer is 1000 newtons. That is the unbalanced force. Let's move on to FT graph. What are these FT graphs? So the unbalanced force, the variation of unbalanced force with the time is known as FT graphs. So area under the graph of FT graph gives you change in momentum or impulse. This is time, this is force, this is the variation of force with the time. Area under the graph, area gives you F into T, which means impulse. Our conclusion is Ft equals mv minus mu using Newton's second law. Instead of Ft, you can take that as I. So I equals mv minus mu. Considering a graph like this, how would you get the effective impulse or effective change in momentum? So here what you have to do is take the area of this and take the area of this, then get the difference of these. So effective impulse gives you A1 minus A2. So the main important thing is, when considering the y-axis, there should be unbalanced force exerting on the object, unlike the normal force. As a third case, we can consider, in example, you are given the variation of reading with the time. For example, a man on a compressed balance tries to jump up. So then what happens? The variation of reading with the time can be varied just like this. Can be varied just like this. So this gives you the weight of the man. So in order to get the unbalanced force, you have to remove this area. Only you have to consider is this area that gives you the effective impulse. Effective impulse. For example, the variation of unbalanced force exerting on the object with the time varies just like this. Varies just like this. You are given this force is 10 newtons. This is 2, 4 and 6. You have to find the impulse, change in momentum. So what you have to do is take the area of the trapezium. So then what happens? 6 plus 2 divided by 2 into 10 gives you the impulse. Let's move on to principle of conservation of linear momentum. Principle of conservation of linear momentum. What is that principle? If the unbalanced force exerting on the object is 0, the momentum of the object is conserved. That is known as principle of conservation of linear momentum. Linear momentum. So we can consider Newton's second law, F equals mv minus mu divided by t, and since F equals 0, the Ft multiplication getting 0, and if you take the mu as P1, mv as P2, what happens? P1 equals P2, which means initial momentum and the final momentum getting equal if the unbalanced force is 0. If the unbalanced force is 0. Now we can consider collision. Considering the collision, we can apply that principle. Here, what you have to do is, you have to equate the momentum before and after collision. Before and after collision. If you take the initial velocity of capital A as u1, capital B as u2, after collision, the velocity of the objects as v1 and v2, we can apply conservation of linear momentum considering this direction, which means the momentum along this direction is positive, then the momentum opposite to this direction is negative. So considering capital A, momentum m1 u1 plus m2 u2, which is equal to m1 v1 plus m2 v2. This is the equation. And how would you get the loss in kinetic energy here? Loss in kinetic energy, you can take the difference of kinetic energy, the kinetic energy of kinetic energy before collision minus kinetic energy after collision. Kinetic energy before collision half m1 u1 square plus half m2 u2 square minus half m1 b1 square plus half m2 b2 square. This gives you the loss in kinetic energy. Now we can consider example just like this. A bullet of mass 10 grams moves with 1000 meters per second, and there is a wooden block there. Then after collision, bullet is inside the wooden block. If the mass of the wooden block is 990 grams, you have to find the velocity of the combination. So here we can apply conservation of linear momentum. What is the momentum of the bullet before collision? It should be 10 grams into 1000. So here no need to convert the gram into kilogram, because you have to consider the mass of the system after collision as 1000. This is 1000 grams now into V. So then V equals 10 meters per second. 10 meters per second. Now we can move on to another example. Object of 10 kilograms and 30 kilograms is connected with a spring. Initially the system is at rest, then the string is cut. If the object, the capital A object, moves 10 meters per second, you have to calculate the velocity of B object. Here again we have to make use conservation of linear momentum regarding particular direction. And here what you have to do is you have to consider momentum of the object before cutting the string and after the cutting should be equal to each other. So before cutting momentum is 0, after cutting 10 into 10, that momentum should be negative. 30 into V, it should be positive. Then what happens? V equals 10 divided by 3 meters per second. 10 divided by 3 meters per second. Now we can move on to Newton's third law. What is Newton's third law? Every action has an equal and opposite reaction. For example, when two objects contacts with each other, A and B, let's consider this force is Fa and this force is Fb. What is Fa? force exerting on B given by A, and FB force exerting on A given by B. So these forces equal in magnitude, opposite in direction, same line of action, and these action and reaction exerting on two different objects. Very important point is the action and reaction exerting on two different objects, unlike one object. We can conclude, according to the Newton's third law, each and every force consists of couple. Now we can move on to the types of forces. What are the types of forces? One is gravitational force, second one normal reaction, third one tension, fourth one thrust, fifth one friction. Those are the types of forces. Now we can consider the first one, that is gravitational force. Gravitational force can be considered as W, or weight occurs due to the gravitational field. When an object is in gravitational field, there is a gravitational force. When considering an object on an Earth surface, what happens? There is a force exerting on the object given by the center of Earth. That force is considered as weight. Considering a figure like this, how would you mark the weight of this object or the gravitational force? It should be perpendicular to the surface, which means that line of action is along the line joining of two centers. So this force is equal to mg, weight. Now we can move on to the normal reaction. When an object contacts with another surface, there is a chance of occurring normal reaction. If the object contacts with a surface, what happens? The normal reaction should be perpendicular to the surface. Normal reaction, it should be perpendicular to the surface, just like this. This is R1. Considering this, what happens? This is wall, this is floor. You can consider a ladder like this. What happens? The ladder connects with the wall. What happens? The normal reaction should be perpendicular to the wall, unlike the ladder. This should be here perpendicular to the floor. That is the first instance of marking normal reaction. What is the second instance? When the object contacts with knife edge, the normal reaction should be perpendicular to the object. Normal reaction should be perpendicular to the objects, just like this. Here what happens? If the knife edge is there, the normal reaction should be perpendicular to the ladder. Considering the third instance, if the object contacts with curved surface, just like this, what happens? In order to consider the normal reaction, you have to create the tangent first. It should be, the normal reaction should be perpendicular to the tangent. This normal should go through the center of sphere. Center of sphere. These three are the ways of marking normal reaction. Now we can move on to the tension. Third one, tension. Tension occurs due to the connection between string and object. Here we are considering a massless string, therefore the tension is same at each and every point on the string. In order to mark the tension, it should be along the string towards each other. For example, if the object is hung by a string, what happens? You can consider this is the boundary of the object and this is the weight of the object. This is the tension. Tension T1 given by the string on the object. T2 is the tension given by the string on the roof. Considering the string, what happens? Considering the string. So if you consider your object as the string, you have to mark the reaction force of T2, which can be taken as T2 dash, as well as reaction of T1, which is T1 dash. What is T2 dash? T2 dash is the tension given by the roof on the string. T1 dash is the tension given by the simple M on the string. So all these physical quantities, all four physical quantities equal to each other. Like T1 is equal to T2 equals to T1 dash is equal to T2 dash. This is the way of marking tension. Considering another instance, here there is a pulley and two objects are there. If the masses are M1 and M2, you have to consider the weight of this object as M1G, and this is tension T1, T2, T3, T4 and so on. This is M2G. What happens here? All physical quantities, considering tension, should be equal to each other. But this T1 means the force or tension exerting on simple M. T2, tension exerting on pulley. T3, tension exerting on pulley. T4, tension exerting on M2. The fourth one is thrust. When there is a rod or the rod involves with the object, what happens? Thrust occurs. In order to mark the thrust, what you have to do is consider the rod and mark the opposite direction of the previous procedure in marking tension. This is the tension. This should be rather thrust. This is the way of marking to thrust. T1 is the thrust given by the rod on the cart. T2 is the thrust given by the rod on man. T1 should be equal to T2. So how would you mark the reaction of T1 and T2? Here you have to consider the rod. Then you have to mark T1 dash, T2 dash as well as T1 dash. This is the way of marking thrust. On to friction. The most important thing is friction. What is friction? Friction occurs when one object tries to move respective to other contact surface. When two surfaces are contacted with each other, when an external force is given just like this, what happens? The friction occurs. Friction occurs. When the external force increases from 0, 1, 2, 3, 4 and so on, what happens? Friction is also increased from 0 to 1, 2, 3 and 4 and so on, which is equal to the external force. But the thing is, the friction cannot be increased up to infinity. There is a maximum possible value for friction that is known as maximum static friction, Fs. Maximum static friction. That maximum static friction is directly proportional, which means Fs is directly proportional to the normal reaction. Then the proportionally constant is mu s, therefore the equation becomes Fs equals mu sr. Mu s is the coefficient of friction, static friction, that depends on the nature of the contact surfaces. What happens when P increases? The object tries to move, object tries to accelerate from its equilibrium position through limiting equilibrium position. Then what happens when P increases? Object starts to accelerate. Here there is a friction exerting on the object even the object moves. That friction is known as kinetic or dynamic friction. The symbol is Fk. That Fk is also directly proportional to normal reaction. So what happens here? Fk is equal mu kr. Fk equals mu kr. And the other thing is, since mu k is less than mu s multiplying by r, what happens? Fk is slightly less than Fs. Slightly less than Fs. Now we can move on to the variation of friction with the external force. What happens? As we mentioned earlier, if the external force is 0, friction is 0. When external force is equal to 1, 2, 3 and 4, what happens? The friction is also equal to those values. But the thing is, there is a maximum possible value for friction, that is known as Fs, that is static friction. Then what happens? There is a small drop when object starts to accelerate. When the object accelerates, there is a friction called Fk. There is a friction called Fk. When the mass of the object is half, what happens? Fs is also getting half. As well as the Fk value. Fk value is also getting half. This occurs when R equals mg. This occurs when R equals mg divided by 2. Mg divided by 2. We can move on to another graph, which is the variation of friction force with the incline angle. If the object is on a horizontal plane, then the plane is inclined. The variation of the friction on the object with the angle can be plotted as follows. Initially, there is a friction which varies as a sine curve. Then when it starts to accelerate, there is a small drop and start to accelerate. The variation of friction with the angle is kind of a cos curve. This is known as sine curve and this is known as cos curve. What would be the reason for those? Considering first one, when the angle is theta, if the object is still in an equilibrium position, we can conclude that the friction is equal to the component of the weight along the inclined plane. This is mg sine theta. So F equals mg sine theta. This force or friction depends on sine theta. That's why this variation obeys sine curve. Now we can considering the acceleration. When there is an acceleration, what happens? There is another friction, but which is equal to Fk. What is Fk? Fk is mu kr. So in order to get an idea about the friction, you may have to find the normal reaction. This should be beta. Therefore, this component becomes mg cos beta. R equals mg cos beta. Considering the equilibrium of the object perpendicular to the inclined plane, therefore the friction is equal to mu k mg cos beta. Our conclusion is F only depends on cos beta. That's why this variation is a kind of a cos curve. Now we can consider another curve. Which gives you the variation of external force with the time. You are given that the variation of external force with the time, a curve like this. So then what would be the variation of friction with the time? So if the maximum external force, the P max is less than Fs value, what happens? Less than Fs value, the object not gonna be moving. Therefore, the variation of friction with the time should be same as the given curve. But if it is vice versa, what happens when Fs is greater than Pmax? Fs is less than Pmax. What happens? At one stage, object going to be accelerated. Therefore, up to the acceleration, up to the in equilibrium, what happens? The variation of friction, same as the external force, then there is a small drop and there is a constant friction as it starts to accelerate. These three are the variation. Now we can move on to the examples under Newton's law. The first example, you have to find the acceleration of these two objects. This is 3 kilograms, this is 2 kilograms. You have to find the acceleration and the tension in the string. Considering this object, the force is weight, the first one 30 newtons. Now you can consider tension is equal at each and every point on the string. This is 20 newtons. This goes up, this goes down with the same acceleration. Considering 3 kg, we can apply F equals ma to the downwards. 30 newtons is plus, T is minus, mass is 3 into A. Considering 2 kg, we can apply F equals ma upwards. T minus 20 equals 2A. This is second equation. Take the addition of these. Then 10 equals 5A. A equals 2 ms minus 1. As well as we can find the tension using second. T equals 20 plus 2 into 2, that is 24 newtons. Let's move on to another example. An object is kept on a horizontal plane of mass 8 kg, connects with 2 kg. Considering this object, the weight is 20 newtons, you can take the mass of this object as 8 kg. Tension is equal, and this should be 80 newtons. This is normal reaction. Acceleration downwards, this is towards right. Then considering 8 kg, T is the one and only force that is acting as unbalanced force. Mass is 8, acceleration is 8. Then considering 2 kg, you have to apply F equals ma to the downwards. 20 minus T equals 2 into A. This is first equation. Second equation, add them up. What happens? T cancel off. Remainder is 20 equals 10A. A equals 2 ms minus 2. Using first equation, T equals 16 newtons. 16 newtons. Now we can consider the third example as just like this. 2 kg and 1 kg objects are there. There's a unbalanced force like 30 newtons. You have to find the acceleration of the system and the contact forces. So it's better to consider the system. Considering the system applying F equals ma, the one and only force is 30, mass is 3, acceleration need to be found. So here there is a force like this, but those are getting cancelled off. So the acceleration becomes 10 meters per square second. Now we can consider 1 kg mass. Considering 1 kg, applying F equals ma, one and only force is R, mass is 1, acceleration is 10 newtons. This is the way of getting the answer of acceleration and the contact force. Now we can consider the motion of helicopter. Here you may have to consider that the area of the fan is capital A and the velocity is v. Considering 1 second, the distance made by the displaced air is v meters. Then we can conclude that the volume of the air is pushed by the fan is AV. This is volume per unit time. If the density of the air is rho, we can get the mass of the air which is pushed by the fan, that is m naught divided by T, or m divided by T, that is AV rho. Now we can apply Newton's second law on air. F equals m divided by T into v minus u, m divided by T, AV rho. Final velocity is v, initial velocity is 0. So AV square rho is the force exerting on the air. According to the Newton's third law, there is a force given by the air such as AV square rho. This is the weight. Now we can consider acceleration of the helicopter. Applying F equals ma upwards, AV square rho is the force minus weight equals ma. Then AV square rho equals m into g plus a. Now we can find v as m into g plus a divided by a rho, root of that. That gives you the velocity of air in order to accelerate the helicopter to the upwards. Now we can move on to the motion of rocket. Considering a rocket there is a exhausting gas by the rocket. You can take the mass of the exhausting gas in 1 second as m dot and the velocity of the gas relative to the rocket. The important fact is relative to the rocket can be taken as v. Then we can calculate that force as F naught. According to the Newton's third law, the thrust can be taken as F naught. If the weight of the rocket is mg, we can find the acceleration of the rocket. So in order to get F naught, we have to consider that exhausting gas. Considering exhausting gas, what happens? You can apply F equals m divided by T into V minus U. M divided by T is the rate of mass which is exhausted by the rocket, that is m dot as we got. The final velocity is V, initial velocity is 0. The final velocity should be the velocity relative to the rocket. So F naught gives you m naught into V. Now we can apply F equals ma, considering rocket. The upward force is F naught, downward force is weight, is equal to ma. So now we can find the acceleration of the rocket as F naught minus mg divided by capital M. That's all. What is F naught? F naught is the force given by the exhausting gas. M is the mass of the rocket. A is the acceleration.